So yesterday we saw the details about introduction to Spark SQL. We saw about the data source API. We gave details about the data frames. Then Spark SQL parser and the catalyst. Then the Hive thrift server where it fits, and the tungsten. Finally, I also described how an end-to-end example architecture will look like, and where Spark will fit, where other frameworks will also fit in. And then we saw one example of how to load CSV data. Schema inference, how it happens, what is the penalty it has to pay to infer the schema, and most of the time we try to explicitly specify the schema. Next are all a bit simple example. We'll see that example to understand how to load the data from JSON file. Sorry. Try to keep it. I will draw it once again. So we know that we have our data source API. So different libraries exist here: CSV library, JSON library, Avro library, RK, RDBMS, NoSQL. So different libraries exist. So and it can read data from any of these structured data: CSV file, JSON file, XML file, all these. So let's see how to read the data from a JSON file. It is much more simpler. So you have to just search for Control Shift N, search for JSON. So JSON file.scala is the program. So as usual, we have seen everything as it is, like Spark conf object, Spark context object, and the SQL context object. Once you have the SQL context, you use the same data source API. You use the same data source API to read the data. Only thing is the format has changed. Either you specify the format in this fashion, or you specify the format in this fashion. Then we are just saying load and the path. Load and the path here. So in this case, I'm using the sales.json file. So this is our sales.json. It's the same sales.csv, but what we have done is we have just written it in a JSON format. Transaction ID is this, customer ID is again in the JSON, item ID again in the JSON, amount paid is again in the JSON format. Key value pair you can think of. This is one JSON record. This is the second JSON record. So that's how our JSON record looks like, and we don't have to do any extra things here. Just read dot format dot loop. That's all is required. So the input is as usual sales dot JSON here. Again, we are saying print schema and show. Show is the action which will trigger the DAG. So as you can see here, print schema has determined, I mean to say, the schema has been determined here. Amount paid is double, customer ID long, item ID long, and transaction ID long. And also, we are getting the data in the form of a data frame. So irrespective of whether you are reading a CSV file or a JSON file or an XML file, you will always end up in a data frame which looks like a table. So once you have a table, you can give any kind of queries on top of that. That's how it makes as simple the Spark. The source could be anything. So Spark helps you to read any data and you can give queries on top of that. So we are not giving any queries as of now because we are just seeing how to load the data, just to see how the data load happens. Now the problem with the JSON is, sorry, not the problem, the limitation of the JSON is nothing but, so you cannot have a multi-line JSON. I will just rename it. I have just created one more file, sales multiline.json. So this is a multi-line JSON. So if we have such a record, it will not work. Let's say this is our JSON record. So Spark will be not able to process such records. So let's see how it looks like. Sales hyphen multiline.json. Let's run this. So as you can see here, it says some corrupt record. Just it is displaying the data, but it doesn't know what is there in that data. So it just says it is a corrupt record. Everything it will treat it as a string. Now, why it is not possible to determine the schema, or why it is showing it as a corrupt data? If the same data is on a single line, it works fine. But if it is on a multi-line, why doesn't it work? Any guess why doesn't it work if it is a multi-line JSON? No, we don't. We should not iterate. Right, right. Here we know that always there has to be a record delimiter. When we talked about the input formats, I always said that there has to be always a record delimiter, because your data may be divided in any fashion. Let's say this is our block one. You have your sales dot hyphen multiline dot JSON file. So that JSON file is, let's say, is divided into three blocks. Block 1, block 2, and block 3. So task 1 will be reading this, task 2 will be reading this, task 3 will be reading this. Now if it is a multi-line, it will be something like this. This is one JSON record. So it will look something like this. Because the blocks will be divided on the size, 128 MB. Each block of a file will be 128 MB. Obviously, it will not coincide with the record boundary. So as you can see here, this is our last record in block 1, which is partially available in block 1, and rest of the data is available in block 2. Now task to read pointer is pointing here. So when it sees, it doesn't know whether it is a start of a record or a end of a record, or where it is. It doesn't know what it is. Also, there is no delimiter also. Your record boundary also, it's not there. How does it know the task that this is the end of the record? It could be some nested also. I mean, it cannot verify that. It doesn't know whether this is the start of a new record. So there is no way to know whether it is a start of a record or a end of a record. So that's the reason a multi-line JSON reading in the distributed processing. It's not just related to Spark. Any distributed processing framework you have, so it cannot read a multi-line JSON record. It has to be on a single line JSON record. So this works fine because this one record JSON record is on the same one line, meaning that /n is the delimiter. So task one will read up till the /n. So after the /n, it will know that it will be a new record. So that's the reason multi-line JSON does not work. So I hope that was clear. I hope why it is not possible to read a multi-line JSON record. Yeah, I assume it is clear here. Now there are some companies apply some proprietary solution. Here is a question: what if it happens us to provide in a multi-line? So you are saying that you are saying that you get the data as a multi-line JSON from your client. That's what is the question. Yes, Rohit, that's correct. Any distributed processing is the same problem. Yeah. As I said, some companies do come up with the proprietary solutions. So the proprietary solutions are like you consider one of the fields inside the JSON. You consider one of the field, like we will say transaction ID. So you write your program in such a way that as you come across the transaction ID, you will know that this is the next record. As soon as you come across the transaction ID, you will say that is the next record. So I see using delimiters like comma at the end of the record. So you are saying where you will put the comma here. Here you are saying
Yeah, actually, we were using JSON files in our project. So we define the JSON in multiple lines. So when we are defining this one, we define in this way, but we manually specify a delimiter at the closing way. So our processing will be notified that till here is the record length.
so. This way you are saying, right?
Yes.
It could be. It could be. But that's what. Those are all the proprietary solutions. So these are not the generic solutions. It will not work for a generic JSON file. It will be your proprietary solution. Similarly, other proprietary solutions will be there, like you consider the transaction ID. As soon as you encounter the transaction ID, you will say that it is a new record. As soon as you see this comma, as soon as you see this comma, you will, I mean to say, after the close flower bracket, if you see a comma, it is again a new record will start. But if you have a comma, I don't think so. Comma may not always work, I think, because you have transaction ID 111, then you have let's say address. You have address in this fashion. Street is something 20, 21, something. Then city, BLR, state. So this is a nested JSON. This is a nested JSON. So here also you will have a comma, because this address is ending here. So if you have it on a multi-line, then how does the parser will know whether this semicolon, sorry, this colon, because your record has not yet ended. Some we have job, title, company name, something like this. Something like this. So as you can see, this is a nested JSON. Now how does the program know that whether this is the end of the record or this is the end of the record? I mean, it will be tricky to specify a semicolon. Probably some other ASCII character would work instead of semicolon. Sorry, comma, instead of comma, some other ASCII character may work here. Probably your JSON record did not have a nested JSON. If there is no nested JSON, obviously it will work. If it is a nested JSON, comma may not work. In that case, some other, you can have something like hash as the delimiter. Obviously, as soon as it sees some hash here, it will know that it is a new record. So this one,
Yeah, this one I was just using in my Python code, and if I give these multiple records with the comma specified in there, and it is working well. I mean, it will read as a dictionary, and if I call these dictionary objects, in my programming, that will call perfectly. I mean, with these, let's say if I'm calling all the names within this people's object, it will call all the names of the people's in here like that. I mean, this one is working fine.
in you are saying Python,
Yes,
Spark Python. You are saying,
yes, PySpark.
okay.
Just even if you if you can open this PySpark in your uh, Linux machine and just type this code and read as a JSON, it will work.
Yeah, I haven't tried the PySpark actually. Let me. I don't know how it works.
PySpark or even Scala also, you can just call this as a JSON library. With JSON library, then it will work.
A JSON library you are using.
Yeah, I mean, to read this JSON file, we need to have JSON libraries,
A
right?
JSON library. Are you talking about the data source library in this fashion? I mean, are you trying to read in this fashion
Yes,
using
through data source. Yeah,
data source API itself?
yes.
That's strange because we just now read it through the data source API itself. This itself is not working. So if I put this also, I don't know whether it works or it doesn't work. Just for simplicity purpose, it says it's a corrupt record. So can you share the file actually if you have the file? I mean, we can take it offline. I will try to run it,
Yeah.
check it
Can you
offline.
pass on to me? I can show it here.
Sorry.
Can you pass ball to Anand Rajaraju?
Oh, you want me to share your screen?
Yes.
Okay, okay.
Pramod, it's not for Anand, it's for Anand Gajaraju. It's in my office laptop. I logged
Oh,
in from home.
okay, okay.
So let's say I'm calling an object like this.
No, you are passing it as a string.
Yeah, I'm taking this as an entire string, and that string will be no,
Yeah, yeah.
uh,
JSON, you are just saying uh, it has one string. It is not a file. So if you put the whole thing, then one more record in a file, so it will fail. It will fail.
I mean, if we are not using this one and we are just using these in a file,
Right. Similarly, multiple files you multiple just copy paste multiple times in a single file and just try to load that. So import JSON you are doing here. There is something.
yeah, I'm just using this.
This is different. This is not the data source API. I think this is a normal JSON parser, which can parse any JSON record.
Okay.
JSON is a normal JSON parser. It is not a distributed parser. It is a simple parser which can parse any JSON records. That's the reason. Even if you put it in a file, it will work.
Okay. Let me try. I mean, I do have other samples. Let me try on this one. I'll check with you offline.
Right, right. It will work. It will work because it's a single system JSON parser. It is not a distributed JSON parser. When we have distributed JSON parser, that's where the problem is.
Okay.
Yeah. Uh, so if you want to do that things, that is one of the solution. I mean to say, either have some a special character, either have some special character, or treat one of the fields as the delimiter. So as soon as the code looks for the transaction ID, it will say that it is a new record. But it is not so straightforward. So if say you have a multi-line JSON record, it is not so straightforward to determine how you specify what is the delimiter. So as I said earlier, we whenever we are reading a normal text file, we use text input format. So this is the built-in class available in the input output module of MapReduce, which is again used in the Spark also. Similarly, people have developed JSON input format. Earlier it was not there. Some third-party people has developed here. Similarly, XML input format. Again, this JSON input format treats each line is a single record. You cannot generically define a multi-line JSON input format, which will have a JSON record reader. So which will this record reader, it will read each line because each line is a JSON record, and it will convert the key value pair into a hash map. Here key will be offset as usual. Key will be offset. Value will be whole line content. Same, it's the same as because we will treat each line as a record. Now value is in the form of a dictionary form. Value is in the form of a dictionary or key value that will be converted into a hash map. So each record will be a hash map. So that's how the JSON record works. So this is how it is. So if you want to parse a multi-line JSON record, just like a JSON input format is there, in a similar fashion, you have to write JSON mul- multi-line input format. So you have to write your JSON multi-line input format, and you have to write a multi-line JSON record reader. here the record reader, here you need to specify what is that delimiter, whether you want to have hash as the delimiter or a field member. Field is the delimiter. Field is the delimiter. So that's how you have to write. So I will just show this. I will just show this how it is written, which is again for single line JSON record. This code is also available. This code is also available. It's available in GitHub. You can integrate that code with your Spark code. So I will just show how to do with the single record. You can try it with the multi-line record. It should be similar. It should be similar. So as so just go back to open, go to the file menu, reopen the Spark core. Spark core, I think I have already opened it. So I have one more window, Spark core. So if you go to the testing folder, in the testing folder you will see JSON. This is a Spark core project. In the testing folder you have JSON. So there will be JSON input format just like text input format. Again the assumption is one line per JSON object. I think one JSON object per line. One JSON object per line. So just like text input format is defined, JSON input format will be defined. Just like a normal line record reader is defined, here also a record reader is defined. So that record reader uses, we are creating a JSON record reader. So this is our JSON record reader. As I said, key will be the long writable which represent the offset. Value will be in the form of map writable, because value is in the form of the whole content of the record is a value. This will be your value. Offset will be 0. This will be the whole value. As you can see, this could be represented as a hash map. This could be represented as a hash map. And in the Hadoop world, hash map is nothing but map writable. So you define a record reader, you create the object of your here line record reader, because each line is a record, and the logic, actual logic is written here. The method is nothing but next key value. Give me the next key value. This method will be called every time to read the records. So it will read the next key and the next value. Key will be the offset. The value, as you can see here, as soon as it reads the whole line, a JSON parser is being used. JSON parser is being used. So that JSON parser reads the data. This decode line to JSON is the method. This is uh, this is what we have to write. Import the JSON parser, and write all these things. Convert the JSON object to a hash map. So we have our map value, map key, and map value. So that's how the data is read in a customization format. I mean, this is not required actually, because this is already built in your data source library. What I'm trying to say is, in a similar fashion, you have to specify the multi-line JSON record. Now, how do I use this? How do I use this JSON input format in your Spark program? So if you go to the Spark, as usual, we are creating our Spark con, we are creating our Spark context. Here we are using the internal API, new API Hadoop file. You don't use text file API or a sequence file API. Those APIs will not be working. You have to use the internal API, and you have to explicitly specify that it is a JSON input format. The format is JSON input format, and you have to have this code. And key is long writable, value is map writable. So you read the data using this API. Obviously, you will get an RDD. You will get an RDD. RDD key will be this. Value will be this. So we don't need the offset. Hence, we are only returning the value part, underscore dot underscore. So if you hover on this, you can see that RDD of map writable. You are getting an RDD of map writable. Now map writable you cannot directly decode using the Scala language. Scala language does not understand the Hadoop data type. It does not understand map data, writable data type. So just a simple utility I have written, which will convert the Hadoop map writable into a normal hash map. So we get our hash map here. From the hash map, we are extracting all the fields, and we are creating our sales record. So we got our RD of sales. RD of sales record. On this we can do item wise count, all those things we can do. So if I want to do item wise count, I'll say val sales RDD dot map, take each record and transform into a record dot item ID, comma 1, reduce by key. So this way we can do it. We can do it in this fashion. So if at all, so I'm just trying to show, if at all you want to do it for multi-line, you should follow the same pattern. You need to have your, instead of having JSON input format, you need to have multi-line JSON input format. Instead of having JSON record reader, instead of having JSON record reader class, you need to have multi-line JSON record reader class defined. So the logic will be returned in this method of multi-line JSON record. Next key value. Here you have to keep on reading the data, until you see a delimiter. So delimiter could be your hash delimiter, or it could be your uh, JSON, one of the member of the JSON could be your delimiter. That has to be explicitly specified through configuration. So if you search in the Google, so you will see that in a GitHub repository, the Alex Holmes has written an input format. I hope this is a multi-line JSON input format. So it works for the multiline JSON. So if you go to, so you have to download this piece of code and you have to integrate with your Spark application. It will work. You just try it. So as you can see here, here also you have multiline JSON input format. Here also you have multiline JSON record reader. So here put format member. One of the member of the data is taken as the delimiter. So that is through configuration. Just like I said, just like I said. So we can take a name every time we get a name here. Name can be taken as a JSON delimiter. As soon as a task sees a name, it will know that this is the start of the record. Or sorry, people. This is one record I assume here. This is one record. So people can be taken as the delimiter. As soon as we see a people field, we can say it is a new record. So that's how it is done here also. So you can configure people here. So here also there is creating a multiline JSON record reader. This is the method from where you can set which member you want to use as a delimiter. So that will be set in the Hadoop configuration. So if you see the multiline JSON record reader, here here we should be getting that member configuration. So it should be in the configuration. Okay, so first we need to check next key value. So we'll be going through the each and every record next key value. So as you can see here, parser dot next object containing that member will loop through each record until you see this member. Whatever member you have specified, people could be the member. As soon as we see that member, it means it is a end of the record. It is the end of the record. And then you emit the key and value. So this piece of code will work for the multiline JSON record. So you can also see how it is being used. So you probably have to download this piece of code. Probably then you have to download this piece of code, then integrate with your Spark example. Here it is a MapReduce example. You have to write your Spark example. So as you can see, this is a multiline JSON record. Multiline JSON record, it has color name, some hex value, color name, some hex value. So here, color name is treated as a delimiter. Somewhere it has to be given as the input parameter. So as you can see here, multiline JSON input format, set input member is nothing but color name. I mean, you can this can work for any JSON record proprietary way. Everywhere they have to specify their JSON files some unique ID. So if I want to use on my sales.json, I can give transaction ID here. I can give the transaction ID. So anytime it sees a transaction ID, it will know that it is a new record and it will start parsing the record as a new record. So this piece of code has to be integrated. I mean, this may not be required. This is the MapReduce one. This is the MapReduce one. You may have to download these two files and its dependency files. Just try it once. The same way, we have tried it for our JSON format. Download the JSON in multi-line input format, download JSON record reader, and write your own Spark code. Write your Spark code in this fashion. Here, instead of JSON input format, specify multi-line JSON input format. Check what data type key will be long writable. Just check what is the data type of key and what is the data type of value. It should be doable. It will take a few time, uh, a while, but it should be doable in the similar fashion. You should be doable. Otherwise, I will try to write the code. It should be doable. I did not write that code, but we can do that. Just try it. That should be one thing. So I hope you got the idea of why multi-line JSON doesn't work and what is the solution for such a thing. I am just sharing that link on the chat window. You can refer that piece of code. I assume that it is clear why multi-line JSON does not work and what is the solution for that. Okay. Yeah, I hope it is clear for others as well. Now we read the data in this fashion. Now if we have a multi-line JSON record, obviously we cannot use the data source API. Probably we can write our own data source API. I haven't tried this. To some level I have tried, but not for a JSON. For delimiters, which are field delimiters. What I wanted to say is, so if at all your delimiter is something like this. So there is no one single delimiter. There are different delimiters. No singular, sorry, no single delimiter. So in this case, your data source API will not work. The data source API, because if we say it is a CSV, it will look for a comma first. It will look for comma is the separator of individual files. Sorry, individual fields. Individual fields is separated by this. Just to give an example, what I will do is, yesterday I did not show that. So by default, the field delimiter, I'm not talking about the record delimiter, I'm talking about the field delimiter. Sales.csv. We had deleted the header yesterday, so I'm putting it back. Here the field delimiter is comma and the record delimiter is /n. So I'm talking about the field delimiter here. So when we read the data, by default the delimiter is comma. The field delimiter is comma. But if your data is separated by some other delimiter, so you can also specify that delimiter. What I'm trying to say here is, let it read first, later I will change it. So this works fine, there is no problem. So let's say instead of comma I have pipe. So this is our file now. It is pipe separated. It is pipe separated. So when you have pipe separated, it will not work. So you have to explicitly say that delimiter as pipe. You have to explicitly say this. Only then it will work. Otherwise it will throw an error. In a similar fashion, here every field is separated by that same delimiter. Sometimes there may exist one delimiter may be comma, one more may be pipe, one more may be semicolon. So in that case, again the data source API fails. You need to use the regular expression, as your delimiter itself will be regular expression. It could be any of the semicolon or comma or a pipe. So there I had written some custom data source API. It's a bit tricky to write, but it's not impossible. So this also works fine. Sometimes you will have in this fashion. It will fail to parse these records. Such records it will fail because it will be looking for semicolon. So it will treat this as one field. This will be treated as the second field. There will be only two columns in this field. For item ID and item value, it will set it as null probably. So let's check and run this. Actually, I slightly diverted from JSON to here, just to say that for probably that JSON input format, the way it is coded, the same thing could be coded in the data source library also. I mean, in your data source library itself, you write that code. Could be possible. That's what I was trying to say. So as you can see here, the first record, the way it has treated is, this is transaction ID. The whole thing is treated as customer ID because there was no pipe delimiter. There was no pipe delimiter. So in that case, again you have to write your own data source API. Slightly you have to modify the data source library. So regular expression based data source library has to be written. We will see that later. Probably that's not so important. And again, it is a bit complex. It's not so straightforward to solve that problem. But if you want to look into that, the code will be available. I think the code should be available. Training Spark. So Spark, you can check for this code. So you have to write your own data source regular expression. So this is the data source regular expression. So it's not so straightforward. You have to write your own data source library. You have to use your own data source library. Or I will just show it once. Probably. So this is our code. So we are using our 2.x example, 2.x example. As usual, there also we have the data source API, read.format option.load. Everything remains the same. This is our same data source API. But this time, as you can see, we are using our own format. It is not the JSON data source library, nor it is the XML data source library or CSV data source library. We are using our own data source library. And the delimiter, we are just saying that these all things could be the delimiter, comma, this space, or instead of that, we can say pipe. So these are all our delimiters. So using this, we can we can we can parse that. So let's see how we are parsing that. So it is still indexing. It will take some time. The whole code has been taken. This is our main program. This is our actual parser. This is the whole parser that has been taken. I mean, it's not so straightforward. It will be very complex if I explain it. So what we had done is, so we had taken the uh, uh, Spark CSV data source. So this is the CSV data source library. This library takes care of, this is our data source library for reading a CSV file. So this code we took, and this code was changed. So it has all these readers, utils, CSV parser, CSV relation, default source. So this piece of code, this is your whole data source. If at all you want to write your own data source library, it should be in this format only. In a similar fashion, we also have taken the same thing, readers, utils, and our CSV relations. So this reader is nothing but just our regular expression delimiter. So parse line, this is the regular expression we are using. Then we use the normal Java regular expression pattern and match it here. Only if it matches here, it will give the result. So lot of normal Java code, regular expression. Regular expression is, again, it is tough to imagine, but you can do that. But I hope you got the idea here, what I was trying to say. You can try and test this. But I hope you got the idea what I was trying to say. If there is if there is multiple lines, if there is multiple delimiters, then it is then our regular normal data source library will fail. It will fail. In that case, you have to write your own data source library. So if you want to parse such kind of files, you have to write your own data source library, and that library we have written it. It's there in the image. You can use that. So actually, this is a diversion. I did not wanted to discuss this, but somehow I started discussing. So what I wanted to discuss here is we had our multiline JSON record, multiline JSON file. What we did is we used Hadoop API. We used a new API Hadoop, Spark context dot new API Hadoop, and we give the path. So what it returns? It returns an RDD, because these APIs or text file API or sequence file API, all these API always returns an RDD. Now I said that data frames are always faster than RDD because data frames will go through the catalyst and data frames will make use of the tungsten. So because of these two, I said that data frames are always faster. So our goal as a developer should be to always create a data frame. Our goal should be always to create a data frame. The simplest way to create a data frame is through the data source API. Simplest way to create a data frame is through the data source API. Just use SQL context dot read dot format dot load. That's the simplest way to create a data frame. But sometimes, like our case of a multiline JSON, in case of multiline JSON, we cannot use data source API because it will not work. So in that case, we have to fall back to the Hadoop API. Sorry, I mean to say RDD APIs, RDD internal APIs. So in which case it will return an RDD. So but we our goal has to be to create a data frame. So so we have to convert this RDD to a data frame. We have to convert this RDD to a data frame. So it is possible. It is possible. So after reading the JSON file, multiline JSON file, once you have an RDD, you can convert that RDD into a data frame. Later, you start processing the data start processing the data on this data frame, which will be much faster because it goes through catalyst and tungsten. Now there are two ways to convert a data frame to RDD to a data frame. I mean to say, what is extra thing required here? We know that data frame is also a collection. RDD is also a collection. What extra thing data frame requires is the schema. So once you have an RDD, you can explicitly specify the schema. Now schema can be specified in multiple ways. Using case class, struct type, 2df function is there. Schema can be specified in this fashion. Once you specify the schema, it can be converted to a data frame. So if you are writing your own, here again you have to write your, for multiline JSON, you have to have your own JSON input format, multiline JSON record reader. Then you write your Spark code, which will make use of those Java code. Then it will create a data frame. Sorry, it will create an RDD. Now you have to convert your RDD to a data. I will just show a simple example how to convert an RDD to a data frame. So the first example is case class. You have to just search for case class. So how do I can specify the schema? How can I specify the schema here? There are few other things we need to understand. So as usual, let's take the normal. We are reading it through the text file because it is a simple CSV file. It is a simple CSV file. We will read the data using the text file API. Obviously, we'll get the sales data, which is RDD. This is our RDD. Now this RDD also has the header because our file contains the header. As you can see here, this file contains the header, and I will change everything here. I will make it as a normal thing. So as you can see, our data also contains the header. But when you create an RDD, header should not be there in RDD. RDD is just a collection of records. It will not contain header. If it contains header, it will also treat that it is also one of the record. It will not treat it explicitly as a header. It will be treated as a one more record. So you have to remove that header from your RDD. So how can you remove the header from an RDD? How can we remove the header from the RDD? So this is how we are removing the header from the RDD. It looks completely different to what we are doing here. The simplest way to remove a header is I will just say val temp is equal to raw RDD dot filter. Take each string, say starts with starts with so this is the simplest way to remove the header. It is the simplest way to remove the header, meaning it will check whether your record starts with transaction ID. Obviously, this starts with transaction ID. It will be filtered out because I'm using the uh, not symbol. Right. So in that case, it will be doing it will also go for the next record and check whether the transaction it exists a transaction ID. Again, it will check whether the whether the it starts with transaction ID. Again, it will check for the next record and so on. It will do this check for every record. Suppose there are some 10 million records. Suppose there are 10 million records. Just to remove one record, just to remove one record, it will go through all the 10 million records. It is simpler form of, but it is not efficient way to remove the header. This is the simplest. You just have to write the code. This is the simplest, but it is not efficient way. The more efficient way is to use map partition with index. Map partition. I think Karthik uh, has said that it does a full scan. Yes, that's correct, Karthik. Now, how can we avoid doing the full scan? So that's where this map partitions with index comes into. We have already seen map partition. What does map partition higher order function will do? Map partition higher order function is a function which takes a function to which will be passing the whole partition as a parameter, which will be taken as a iterator. Now with index means we will also passing the index. The function will also take an index. So we know that we have our records here. Record 1, record 2, 3, 4, 5, 6, 7, and 8. Record 9, 10, 11. So when we define a map partition, so we are passing a function. Now this function, this function takes the whole record. I will say function f1. So yeah, to f1, record 1, record 2, record 3, record 4. Whole thing will be passed. Now when we say map partitions with index and we say some function we pass to that function, actually that function takes two parameters, the index and the whole collection. Now what is the index here? Index is nothing but the partition number. So this is zeroth partition, this is partition number 1, this is partition 2, this is partition 0, this is partition 1, this is partition 2. So what it says is 0 and record 1, record 2, record 3, record 4. Here partition will be 1, comma, record 5, record 6, record 7, record 8. So this function takes, sorry, partition as 2, and record 9, record 10, record 11, and record 12. So now we just say, we'll write the logic as if index equal to 0. If index equal to 0 means this. We drop first element from here. We drop the first element. Obviously, we'll not be going through any of the other records. Here also we'll be not doing anything. We will not go through the records. Here also will not go through the entire records. We'll just check whether here only the checkings will be done. Here also the check will be done. Here all the checks will fail. Here only the check will succeed and this record will be. Here all the checks will fail. So here only the checks will succeed and the record will be dropped. That's what we are doing here. So I am passing the function literal. I am passing the function literal with index and partition. And the body of the function is nothing but if index equal to 0, from the iterator drop the first element. If index equal to 0, from the iterator drop the first element and return the remaining. Otherwise return as it is. For all other partitions, don't do anything, return the iterator as it is. So I hope you got the idea. This is an efficient way to delete a header from a RDD. So we got our RDD now. It is nothing but RDD of string. We read the data, we deleted the header. We are just having the records now. Once you have the records, which is an RDD of string now, you have to convert it into an RDD of some class object, especially a case class object. You have to define a case class and class. There is not much difference. There are some methods which is automatically implemented by the compiler, like compare method, equals method, some then toString method, hash code methods. It is just like your Java bean class. Some methods will be automatically implemented by the compiler. There is no difference between normal class and the case class. Usually case class are used to represent a record. So here somebody has asked, if I have 5 files and in all the files if I have header, how can I ignore header in all the 5 files? So if you have 5 files, all the 5 files you have to read separately. You have to read. There are 2 ways to do that. The question is this. I will. If I have 5 files and in all the files if I have header, how can I ignore header in all the 5 files? So what you can do is, all the 5 files are in one folder. All the 5 files are in one folder. You just read the files in the folder. It will read all the files data and you will get an RDD. Now use the filter higher order function to remove the header. That is one solution. Filter function, just like I showed. Filter function is to just check whether it starts with the header characters, then you filter it out. or use the map partition with index. It will be a bit tricky. I don't have the code here. So there is an API in the Spark dot whole text file. Just like we have Spark context dot text file API, just like we have this, there is one more API called whole text file. So what it does is it returns an RDD. It returns an RDD. Now how will that RDD will look like? It returns the RDD with key as file name and file content. Again file name, file content. So if you want to read all the files separately, this is how it can be read. Now you can make different RDDs out of this, and on each RDD you can apply map partition with index. Map partition with index. I mean it's not a straight. I haven't tried. First I will try this. Probably I will give this. So this could be done using whole text file, and then map partition with index. That could be a solution. So I will just finish this one example and then we will wind up. As I said, there is not much difference between a class and a case class. Only thing is the Scala compiler will create some built-in methods automatically for you. Hash method, toString method, equals method, and some other constructor methods and some apply method, unapply method. Some methods will be automatically created to make it more simpler to use. Unnecessarily, the developer need not write all those methods. The compiler can create those methods. And case classes are usually used to represent a record. Now what we are doing here is we got our RDD. Now we take each record of our RDD and we are converting into a sales record. So you can see here. So it is RDD of sales. Now this how it got converted to a data frame? We just use the method called 2df. Now where did it get the schema? When we use the case class, the class name, the class has members. These will be taken as the column names. Transaction ID, customer ID, item ID, and amount paid. All these things will be taken as the column names. Its data type will be taken as the column data type. So we get the complete schema here itself. The class members and the class members data type will itself be the column names and column data types respectively. So that's how you specify the schema as I said here. So the class members and the members data type will we become as the schema, and it will get converted to a data frame. So you have to represent your RDD as a RDD of some class object. It should be represented as a class object so that it can pick up the schema from that class. And then you just say sales RDD to DF. Sales RDD to DF. In a similar fashion, you could have said the same thing for your JSON also. Instead of doing this item wise count here, this is our JSON. You can just say sales RDD to DF, because it is a RDD of sales record. So it should happen this. Only thing is we have to import Spark SQL context So the 2df is not directly available. 2df function is not directly available. You have to import something for that. So that import is nothing but SQL context has some implicits. It has to import those things. First you have to create this SQL context and then import. So it should. So JSON records can also be, you can if you have your multi-line JSON record, first have JSON input format. Similarly, JSON multi-line input, copy those things. Finally, you convert your data into some RDD data. Then use the 2df function, and the schema will be taken from your case class. Finally, you will have your data frame. Once you have your data frame, you can give queries on that data frames, which we haven't seen yet. I mean, what I'm trying to say here is, once you have the data frame, then it becomes simple. Once you have the data frame, it becomes simple because we have to just give the queries here. But getting a data frame sometimes could be tricky. Sometimes based on your data, it may not be straightforward to use the data source API. If it is good enough to use a data source API, then everything works fine. But sometimes the data source API may not work. You have to fall back to RDD, read the data, do custom parsing of your data, convert into a data frame later using the case class. Once you have your data frame, then you can give all kinds of queries. So I hope you got a idea here. I mean one of the thing when you fall back to RDD is whenever there is a custom parsing required, which the data source API is not able to do it. Whenever the data source API is not able to parse your record properly, in that case sometimes you have to fall back to RDD, start writing the code to parse that, then convert it back to data frame and start doing the processing on top of that. So I hope till here things were clear. So we'll wind up the session here, and let's continue tomorrow with other way of converting an RDD to a data frame. We'll also need to see the struct type way of converting the RDD to a data frame, and also we can specify schema. 2df is used for every purpose, for all. So 2df will come here. There is a schema method also, using which you can specify the schema this way, or this way. Then finally use the 2df function to convert an RDD to a data frame. So the remaining we'll see tomorrow. Thanks, thanks everybody, and have a nice day and good night.